Hello, night owls and early birds. Welcome back to Science After Dark. Tonight, we're diving into the fascinating world of chemistry, specifically the quest to discover new catalysts. Catalysts are like the unsung heroes of chemical reactions. They speed things up without being consumed themselves. Think of them as the ultimate efficiency experts in the molecular realm. Now, finding new and better catalysts is a big deal, especially if we want to make clean energy technologies more efficient and affordable. And that's where machine learning comes in. Scientists are using powerful computer algorithms to help them predict which materials will make the best catalysts. But here's the catch. These machine learning models aren't perfect. A recent study published in the prestigious journal Catalysis Science and Technology by a team of researchers including Karim Abdelmaksud, Mohamed Chouaibi, Adish Koluru, Rafael Ichula, and John R. Kitchen has uncovered some interesting issues. The researchers focused on a massive dataset of information about different materials and how they behave as catalysts. They found that the machine learning models were making more errors when predicting the properties of certain types of materials. It was like the models were having a harder time learning the rules for some materials compared to others. So, what's causing this? The researchers investigated two key factors. The first involves something called density functional theory, or DFT for short. Essentially, DFT is a complex way to mathematically model the behavior of atoms and molecules. The data used to train the machine learning models was generated using DFT calculations. However, some of these calculations were less accurate due to shortcuts and approximations, introducing errors that the machine learning algorithms struggle with. But the second factor is even more intriguing: surface reconstruction. Imagine the surface of a catalyst material. It's not always perfectly smooth and unchanging. When a molecule lands on that surface, it can sometimes cause the surface itself to rearrange, causing changes that weren't accounted for in the original calculations. This is a bit like trying to predict the behavior of a moving target. The computer model is trying to learn from imperfect data. The researchers had a clever solution. They suggested that instead of focusing solely on a particular way of measuring energy, which is very sensitive to surface changes, training the machine learning models on the overall energy of the system might give more accurate and reliable results. It's like using a more stable and general metric rather than a specific and somewhat fickle one. So, what are the big takeaways here? First, the quality of the data used to train machine learning models is absolutely critical. Garbage in, garbage out, as the saying goes. Second, understanding the complexities of the catalytic materials themselves, those sneaky surface reconstructions, is vital for building reliable models. And third, a more robust way to approach the data could lead to much better predictions. The work by Abdelmaksud and his team highlights the ongoing challenges and exciting progress in using machine learning to accelerate the discovery of new catalysts. Their findings show that it's not just about having bigger and better models, but also about having cleaner and more consistent data, which will ultimately lead to more accurate predictions and hopefully new discoveries that can help tackle some of our most pressing global issues. Until next time, keep looking up.